Given that the average salary of graduates entering the actuarial field is reported to be $40,000. To test this, a statistics professor surveys 20 graduate students and finds their average salary to be $43,228 with a standard deviation of $4,000. So using alpha equals 0.05, has he shown the reported salary incorrect? So again, just marching through step by step, let's take a look at step 1. So we have to state a null and an alternative hypothesis. So notice here, has he shown the reported salary incorrect? So is this a statement of difference or non-difference? Difference. Is there any direction associated with this difference? No direction. So our alternative is going to be what? Mu is not equal to $40,000. Very good. I think you all were all marching down the same path. So our null hypothesis is mu equals $40,000. So for step 2 is to compute the test statistic. So again, when you compute the test statistic, this is where you ask yourself, am I going to use a Z or a T? So in this case, which one are we going to use, the Z or the T? T. And why is that? Because we have 20 graduates, so N is less than 30. So our T test statistic then is going to equal to X bar, which is 43,288, minus mu under the null hypothesis, which is 40,000, times the square root of n, so we get the square root of 20, and all this is divided by the standard deviation, which we know is 4,000. So when I computed this, I came up with 3.61. Formally, it should be.
It has to be both, or should it just be the standard deviations unknown?
How about if you just run with the sample size is less than 30?
Okay.
We'll just run with the sample size to keep it easy. All right, so step number 3 is, what was step 3? Draw a picture. So we need to now draw a T distribution. So this is our T distribution, so we need to come up with some areas up here. So this is a two-tailed test. Our alpha is 0.05, so how much is going to be in each of these tail regions? 0.025 is in each of the tail regions. And we also need a degree of freedom. So our degree of freedom for hypothesis testing is the same as it was for confidence intervals, so the degree of freedom is always n minus 1. So in this case, our degree of freedom is going to be 19. So you can look up in the T-chart and go to the column of 0.025 on 19 degrees of freedom, or for those of you that have the program that I gave, here's something else you can do. If you just go in here and press the program button, we can choose menu option, whatever your menu, but I'm looking for the inverse T. I believe that's what I gave you. So here the program is asking us to enter the degrees of freedom, which we know is 19. And now, since you can either do the left-tailed or the right-tailed, but it's really not going to matter. One of these is going to be positive, and the other one's going to be negative. So at this point, you can really just pick one. It doesn't really matter in this case. I'm just going to choose one, and you can choose. Why don't you guys choose 2? I'll choose 1, and we can actually see the difference. And then the area, well, the area in the tail is 0.025. Press enter and let it think. This is the little thinking thing up here. So that means it's thinking, if you will. And then it'll come back and give us the t-score, and this thing kind of takes a little bit of time here. Hold on. Negative 2.093, and I believe you would have came up with positive 2.093. So it doesn't really matter which one you choose. So we can go negative 2.093, and this one here is 2.093. So now we need to, step number 4, we need to make a decision based on where our critical value, or where our test statistic falls. So here, we have that our test statistic is 3.61, which is way up here. So our test statistic falls in the rejection region. So step number 4, we reject the null hypothesis. And then finally for step, never mind. Then step number 5, we can come back and we can say at alpha equals 0.05, the data indicates that the average salary for actuaries is not equal to $40,000.